Today we're going to be looking at building a VR model using imported CAD data. The webinar will highlight CAD import capability, CAD simplification, gridding, and post-processing.
So I'll start by bringing in a CAD model. Bring in this step file. We can see a preview of the model here in the window. I'll hit OK. Okay, and I'll just drag this into the domain. I'll resize the domain. In reality, you'd want it to be larger than this, but I'm going to keep it close to the size of the CAD for visual purposes for this webinar. So I'll go ahead and just uninstall these chassis sides, and that will leave us with a domain that is open to the ambient conditions. Okay. So when you go to clean up a model, you typically want to look for small, detailed objects that may not be as relevant to the thermal analysis as other objects. Things like screws, buttons, maybe detailed brackets in areas that are away from major heat sources. All these things can be looked at and considered for helping to reduce your model size and make your life a little bit easier when it comes to the solve. And so for now, I'll go ahead and look behind the curtain here and remove these covers. And so now we can see all of these mechanical components and brackets that hold this together. And now we can identify objects that aren't thermally relevant. And we can see these two brackets at the top of relatively complex geometry with curved surfaces and holes. So this will take a significant amount of grid to capture. We have an option on the right-hand side of the property sheet to adjust the modeling detail. This gives 4 options: full, approximate, ignored, and decorative. Full will add grid to capture features in detail and will add grid to the model. Approximate uses the grid generated by other objects to grid the object. So use this option only on objects that you know are not thermally relevant to the model. Ignored and decorative remove the object from the thermal simulation and all environmental calculations. So these are the 3 options you have available. Typically, we just use approximate. You can select that. And when you go to grid this model, now it will do a more rough job of capturing it. So the next thing we want to look at with regards to cleaning up a CAD model is the Convert To feature. The Convert To feature allows you to convert solid obstructions into native objects. And this tells the software what they are and how to handle them, what to do with them. So for example, here we have a PCB, and what we want to do is we want to just click on that and right-click and convert it. We'll go ahead and convert it to a PCB. Now the software knows that it's a PCB, and if you go into the property sheet, you have a fully parametric options to go in and change your modeling level, add different materials. Everything is fully available to change, add powers. All of this is possible. But it gets even more clever than that. If I select another solid obstruction over here, and I know this is a component, then I can do the same thing. I can go to Convert To and convert it to a component. And you'll see in the model tree that this component has actually been automatically attached to the board because it saw that there was a board nearby and it said, okay, then that must be a component, and it attached it. And so now, if I were to go in and move this PCB, the component would move with it, and it also inherits any other properties as well. And again, everything is fully parametric with this component, so it can be changed in the property sheet. So this process can be repeated for the rest of these components, or you can group select them or use the find tool and select them and convert all of them into components. And now you have a fully native PCB with components that is fully parametric to be adjusted just with a few clicks of the mouse. So now let's talk about adding faces to solid obstructions. So if I select this front cover, and I'll go ahead and show that. So let's say, I'm going to add this to a new view. Let's say that we know that this front cover here has a different coating than the back cover. And we want to capture that for the purposes of radiation calculations. So what we can do is right-click on the object, and we can add all faces. And this breaks the object surfaces into individual face objects, allowing you to provide different properties from the parent object. A good example would be applying a surface with a different emissivity value than the parent object. I can go in and select a different material with a different emissivity. Let's say this happens to be, I don't know, say I go in and find a different material, maybe a plastic. I'll just select ABS. I'll attach and apply. And I could even go in and actually specify some different emissivity or some different material values. So I could say coating, perhaps. And then I could go in and actually change these values here. And once I've done that, I can go to these other faces, or I can even select the entire object itself, and I could change the material for those objects. So FR4 is not likely to be the material that we would use here, but I'm just going to apply it here. And what this will do is it'll apply FR4 to every other material, every other face in the object, except for the one face on the front side that we changed, which will be left as the ABS plastic. Once you've assigned this material, you can delete the other faces. They're always available to be added should you need them for another purpose. Faces can also be used to monitor results on a specific face, for example, the touch temperature. 6SigmaET gives the user full control over gridding their model. And there's a few different ways that you can go about gridding solid obstructions within 6SigmaET. So the first method would be the minimum cell size. If I select a solid obstruction here, I can now get over to the geometry section of the property sheet. And here I'll see an option for a minimum cell size. So the minimum cell size controls the minimum size of a grid cell that is generated on an object. This means that any solid features that are below that minimum cell size will not be captured. So reducing this number will refine the grid and how well that these small features on your solid obstruction are captured. The next thing that you can do to improve or change the gridding within your model is grid controls. So grid controls allow localized control over the gridding of your model. I'll navigate here and I select this cover, and I'm going to go ahead and show that. So this cover, currently, it's just going to be gridded using the standard grid rules. And if I go ahead and show the grid, and let me make sure that's going across here, it is. And I'll make this transparent so it's slightly easier to see. Here we can see the default gridding for this object. If I go ahead and add a grid control to this, let's go ahead and move. And here we have our standard options, and I want to select geometry base. I'm going to highlight that here. So geometry base will actually control the grid based on the geometry of the object that it's dealing with. And to do that, it has three options. So there's the option to apply to the solid, and I think the best way to frame this is in terms of something like a pipe with a fluid flowing through it. I think that's the easiest way to understand these grid controls. And so applying it to the solid will actually apply it to the physical solid of the object. In the case of the pipe, that would be the physical pipe itself. Now, applying to the fluid will apply it to the internal fluid within that pipe. So it'll actually control the fluid within some closed area. And then finally, inflating the fluid will allow you to expand the grid from the surface of the object into the surrounding fluid. And so for something like this casing here, that would be what I would look at using. And so you have the option to apply it to the inside fluid or apply it to the outside fluid. And in this case, I just want to check the outside fluid, and I'm going to give it say a maximum size of 4 millimeters, and then I'm going to extend that maximum size of each grid cell 4 millimeters into the surrounding fluid. Now I'll just go ahead and generate the grid to show you the difference that this will make. Okay. And so I'll speed that up in post to save some time here. That took about 2:45 to grid this fairly large model. And here we can see what this grid control has done. So now we have grid cells that have expanded from this cover into the surrounding fluid, into the surrounding air. So those are a couple of tools that you can use for local grid control within your model. And we also have advanced grid controls. And these are global grid controls that can be controlled using the solution control. If we navigate to solution control and then the grid section, we see a few important options here. So the first we have is the limit refinement ratio. And this will allow you to limit the ratio at which the grid goes from refined grid to a more coarse grid. So that's one thing that you can do to globally adjust your grid control there. Another option we have is the limit maximum cell size. If I check this, it'll give you the option to limit your cell size in each direction within the model. This is one thing you can do to globally limit that maximum cell size. Finally, we have apply smoothing. So applying smoothing will allow you to set a limit for your aspect ratio and your expansion ratio within your model. And if you'd like to check what those values are based on your current grid rules, you can see them down here in the summary below. So that covers what I want to talk about with gridding. So now let's talk about post-processing and results analysis. So surface plots can be used to quickly plot variables on your solid obstructions. Here we'll look at the surface temperature, and we can quickly plot this onto the face of this solid obstruction, on the cover of this. And we can also maybe look at this back plate here, which would be what would be felt by a user when they were wearing this. So that might be useful to know as well. Okay, and we can see it's significantly cooler than the front cover, as you would expect. That means we've done a good job here. So I'll go ahead and just undo that really quickly. And now I will hide this front cover. And I'll show our pre-configured view. So with a couple of clicks, we can quickly look at important values such as our mean surface temperature on our components. And so this really allows you to quickly get through the model and see what's important and what's going on. Finally, I want to talk about result planes. So I'll add a result plane here to the model. And let me go ahead and set this back to object defined. And I'll rotate this to the Z direction and drag it right across this front of this cover. Using a result plane, we can look at a lot of our variables, including our temperature or velocity, things like that. And we can also plot our flow pattern. And here we can actually visually see, and if I change this to something more significant, we can quickly see our flow pattern within our model. And also colored by various things. So here maybe I'll color by temperature, and I can see the hot spots and where this natural convection is cooling this electronic circuit. That concludes our webinar. I hope it was informational and will give you some new tools for working with CAD geometry in 6SigmaET. Thank you for your time, and we'll be taking any questions you have